So you can see 27, it also gives us a piecewise function. So make sure it is continuous or not. So we have to try to prove that three conditions one by one. Before we do it, we draw out our interval first. So for our interval here, they said 3. Less than 3 means 3 from the left hand side is this function. 9 minus x squared over x minus 3. At the value of 3, exactly x equals to 3, you can see x equals to 3, our function is negative 6. And then more than 3, it will be 162x minus 54x squared over x cubed minus 27. They ask us determine. We have to check whether this function continuous at 3 or not. Okay, so we have to prove it one by one. We have to do it step one by one. For the first condition, where we want to check the continuity at x equals to 2, so we have to make sure the function in the value of 3, it have a point or not? It have a coordinate or not? Yes, it have a coordinate negative 6. Means the point is defined. The coordinate for f3 is defined. So when it is defined, we write out our value, negative 6. Condition number 2, we have to see whether limit exists or not. So when we want to see limit exists or not, we have to do our limit x approaches 3 from the left hand side, which is the function 9 minus x squared over x minus 3. So they ask us determine whether it is continuous. So we have to do it part by part. We cannot definitely equal because it doesn't say this function is continuous. No, they ask us to check. So we have to check one by one. Limit left hand side, we check its result. Later we do limit at right hand side, we check its result, whether they're same or not. Okay, so for limit at left hand side, when I substitute this limit, when you try to attempt this limit, 3, we put here is 0 over 0. So when we have 0 over 0, we try to simplify our IDF. When we have a quadratic here, means we have to factorize. So make sure your factorization 9 minus x squared, it will be 3 minus x, 3 plus x. So you cannot inverse the part because a minus b, b minus a will different result. Okay, so this is a squared, this is b squared. So definitely this is a minus b. 3 come first, x come after that. And then 3 come first, the x come after that. 1 minus, 1 positive. So at the denominator here, I can factorize negative 3. When we factorize negative 3, it will give us 3 minus x. I arrange in order, I put the 3 in front, then x afterwards. In order easier for us to see this factor can be simplified. So once we simplify our IDF, we can attempt our limit. We can substitute our 3 inside here. So it will be equals to 6 over negative 1. So negative 6. So that will be our limit from left hand side. So we try another part, limit from right hand side. So we try to substitute our value of 3 here. It also gives us a situation of IDF. So when we have IDF involving polynomial, we can try to factorize our polynomial here. So our factor, when you substitute x equals to 3, so means our factor is x minus 3. For cubic, x cubed, I divide out our factor, x minus 3. So we need a 3 here, 3x here in order to get 3x squared. And then 9. So 9x minus 27. So factorize it completely. Our denominator part will be x minus 3. And then that quadratic is x squared plus 3x plus 9. Meanwhile, numerator, for numerator, we can also factorize. We can take out the x, and then we can take out this 54. So once we take out 54, this is equals to 3. And then we notice that we haven't come to the simplify yet, so we have to do one more simplify here. We try to factorize out our negative in order to get to send to the factor x minus 3. So negative 54x, we take out negative, it becomes positive x minus 3. So finally, we managed to simplify our function. Means our next step, we are going to substitute the value of 3 to attempt our limit. So when we substitute this, it is equals to negative 6. Means the limit is axis. You can see left hand side, right hand side, they are same answer. They are same answer. So we can come out a conclusion that condition 2 is fulfilled. Limit for x at process 3 of the function, it is axis. Okay, so it is equals to negative 6, means it is axis. So condition number 2 is fulfilled. So when we come to condition number 3, okay, why it is axis? Because the limit from the left hand side is equal the limit from the right hand side, which is equal to negative 6. Then we come to condition number 3, whether the point is it same with the limit. So you can notice that the point f3 is negative 6, and then the limit also equals to negative 6. So the condition f3 is equals to the limit. So condition number 3 also fulfilled. When condition number 1 fulfilled, limit fulfilled, condition number 3 fulfilled, we can come up with a conclusion, say that this graph is continuous. This function is continuous at x equals to 3. So this is how we prove a function whether it continuous or not. So it must fulfill all 3 conditions, then only we can come up to the conclusion here. So this is our concept. Concept doing the limit from left hand side separately from the right hand side. Okay, simplify our IDF to get answer. So separately, because we haven't decide whether it continuous or not, so we have to do it separately. When they are same, then only the condition number 2 is fulfilled. So limit at the right hand side, and then simplify the factorize and get to the answer. So finally, we can conclude up. So we can conclude up all these 3 conditions to make this function continuous at x equals to 3. For question B, we finding the limit at infinity. We try to substitute infinity here. Okay, so it is IDF because infinity over infinity. The way we simplify it will be we divide the highest power. The highest power of here is x power of 3. So every term we divide by the x power of 3. Then we simplify our function. And we attempt our limit of infinity. We substitute infinity here. It will definitely 4 over infinity is 0, 9 over infinity is 0, 7 over infinity is 0. So our answer will give us negative 5 over 3. So this is our concept, simplify our IDF infinity over infinity, and then attempt our answer